In this lecture, we're going to take a look at statistical testing, which extends from descriptive statistics. So when we talk about statistical testing, and this goes to inferential statistics, what we are doing is we're applying a set of pre-established equations to determine whether we're going to accept or reject a stated null hypothesis. And so two examples two examples of this, as you can see here, and the first one we'll expand upon in this video, is whether the average salary of Toronto Raptors players at the NBA are different, statistically different from all the NBA players. So all the NBA players represents the entire population. Another research question includes whether muscle protein synthesis is greater if a person consumes 40 grams of protein in one sitting versus 20 grams of protein in one sitting. And the statistical tests that can be carried out depending upon the research design and the research question include the one sample z-test, which is what we'll examine in this video, something called the one sample t-test, a two sample t-test, and a NOVA, which stands for the analysis of variance. But in this video, we're going to focus on the z-test through the calculation of what's called a z-ratio. And recall that a z-score is a transformed score from raw data. And specifically, it's the difference between a raw score within a sample and the group group average divided by the standard deviation of that particular sample. And recall that this is a unitless measure, regardless of the unit of the raw data. And as a result, the z-score is expressed in quote-unquote standard deviation units and defined by this equation, where the z-score corresponds to the individual score in a sample, subtract the average of that sample divided by the standard deviation. So if your sample has units of dollars, for example, then the dollars unit in the numerator would cancel out the dollars unit in the denominator, yielding a unitless z-score, but we can also say that that z-score is expressed in standard deviation units. So for the number of scores you have in your sample, for example, if you have a sample size of 30, you will have 30 z-scores. So there is a unique z-score transformed from each raw score in the sample. Now, the one sample z-test is a statistical test of inferential statistics. So what we're trying to do here is we're going to take our sample and extend it to the population from which the sample was obtained. And the one sample z-test is carried out if we want to determine if a sample is representative of the population. And we're going to do our first example from the previous slide of whether the average salary of the Toronto Raptors in the NBA is different from the entire population of NBA players. And this inferential statistical test is defined by this equation right here, where the z-ratio is calculated from the sample average, and the sample average is that of the Toronto Raptors. Subtract, in this case, the population average. Recall here our use of Greek symbols represents the population, divided by what is referred to as the standard error of the mean. Because we're using the symbol sigma, this is the standard error of the mean of the population. If we didn't have the subscript x bar, this would be the standard deviation. But for the one sample z-test, we use the standard error of the mean. So carrying this forward, based upon the previous equation, we need some information to feed into the equation. The first thing we need is the average salary of the Toronto Raptors, and these are data obtained and calculated from the 2015 year. And so in 2015, the average salary of the Toronto Raptors was slightly less than $4.4 million for the year per player. Now, not all players were paid this, but if we calculate the average, this is what it would come out to. The average salary for the entire population of the NBA that year was slightly more than $5.1 million per player. So we can see here that on average, the Toronto Raptors average player got paid less than the entire population of NBA players. But what's important to note here is that the standard deviation, which is also available for the entire population of NBA players, is actually slightly greater than the average salary of $5.2 million per player here. So what we see here is with the standard deviation that's greater than the actual average, is that these data display a very wide degree of variability. And the last item that we need here are the number of players per team. And so we're going to go with 17 players per team. And we're ready to set our null hypothesis here for determining if the Raptors' average salary is different from the NBA salary. Now, when you take a look at just the averages, you might reasonably conclude that yes, the Toronto Raptors average salary is less than that of the entire NBA. However, what we want to do is to determine if this difference exceeds that of the variability, or that can be determined by random chance. And so we use the null hypothesis statistical approach to do that. So with the one sample z-test, and as the term suggests, we only have one sample, we are basically stating that the Raptors' salary will be equal to that of the population. So we just simply state that the mu is equal to 5.13, which is the population average, stating that the sample average is going to be equal to this, versus the alternative that it's not equal to this. And so the alternative, make note here, the not equal sign indicates that we are going non-directional in terms of the difference here between the sample and the population. So now that we have our information that we need, we're ready to use this equation to determine the z-ratio value. So x bar represents our sample, that's our Toronto Raptors. Mu represents our population, which was given as well. So this is something that would be provided. But what we have here is the standard error of the mean, which is not the same as the standard deviation. So at this point, we can populate our equation by substituting the 4.392 and change $million, as well as the population average of 5,193,000. This should be a comma, not a period, and $66. But we can't quite yet fill in the denominator. And so we use the equation that the standard error of the population mean is the standard deviation of the population. So the sigma would go in the numerator, and that's this value that was determined from the population, divided by the square root of the sample size, not the population size, of the sample size. And that's 17. When you run the math, we'll end up with a standard error of mean of just slightly more than $1.26 million. And by substituting that into the equation, we end up with a z-ratio. Now the dollars cancel out because we're dividing here, of negative 0.63. And we can also say this is in standard deviation units. So because we're using the z-test, we are assuming and we're basing the test on the normal distribution, our bell-shaped curve. And recall that the normal distribution is divided up into particular regions. And what we have here is a 95% non-critical region. And unless stated otherwise, we always consider the 95 versus 5% region. This is what we call a two-tailed test, where we consider both the positive tail and the negative tail. And because we are looking at the 95% non-critical region, the balance of 5% exists on both tails. And what we see here along the x-axis is our data expressed in z units. Recall that the average exists at the line of symmetry, and that's an average of 0. And the positive and negative 1.96 is almost 2 standard deviation units. And to capture 95%, the 95% area underneath the normal distribution is bound by almost 2 standard deviations, so positive 1.96 and negative 1.96. And if our z-score falls within the non-critical region, then we do not reject the null hypothesis. We accept the null hypothesis that it is true with a confidence level of 95%. So we can never say we're 100% confident, but we are 95% confident that our data here, the Toronto Raptors average salary, falls within the 95% confidence region, and it's negative 0.63, suggesting that indicating that the Toronto Raptors average salary is less than the population average. In z units would be 0. So the conclusion here is because the Toronto Raptors salary did not fall in the negative or the positive tail, for that matter, in that 5% critical region, then we say that the null hypothesis is true and the Toronto Raptors salary is not statistically or is not significantly different than the population, even though the averages are different. Because we have to consider the variability, then from a statistical perspective, it's not significantly or statistically different from the population. And that summarizes the NHST, or the hypothesis testing method. And to summarize the steps here, that we'll be using for the rest of the statistical tests is that we first state the null hypothesis in symbols. Sometimes we use words, but typically we use the symbols of uppercase H and the subscript 0. We then follow that with the alternative hypothesis, and unless stated otherwise, we typically go with the not equal sign, non-directional. We choose the alpha level, and unless stated otherwise, we typically choose the 5% risk that we are making a mistake in our conclusions. And we have to determine if we're one or two tailed. And as with the alpha level, unless stated otherwise, we typically select the two-tailed approach. We did not do this in this video, but we would state a rejection and retain rule. And this is based upon the z-value of 1.96. Because we go with the 95% or 5%, the point of that is considered the critical value would be the 1.96. In step 5, we compute the appropriate statistic based upon the data. Those were the z-ratio equations and the standard error of the mean equations that was generated. We then make a decision by revisiting our rejection retain rule. Once again, we did not specifically state this in this particular video, but in the future we will state that rejection retain rule, and that's based on comparing, in our example, the negative 0.63, which was our computed statistic, against the 1.96 value that determined and established the 95% region of non-criticality versus the 5% region, which would be critical. We would then write the conclusions in the context of the study in our example by basically stating that the Toronto Raptors' average salary was not statistically different from the population or the entire NBA. So this ends this video on the null hypothesis statistical testing approach.